So hi everyone, welcome back to another video in our channel. In this video, we are moving on to our next chapter in the DSA series, that is how to manipulate the mathematical logics and how to convert the mathematical problems into the programming logic. So in this chapter, we will deal with interconversions of various mathematical number systems like decimal, binary, octal, hexadecimal. We will see the conversions and interconversions between these mathematical numbers and how can we do that. So for the first video in this chapter, the problem that we are going to tackle is how to convert decimal number into binary number. So before going into the coding, we need to understand how the things work in from the mathematical point of view, how decimal number are converted into binary number in mathematics. Then we can just translate the mathematical logic into our programming logic. So let's dive into the video and take this example, that is 57 over here we have as the decimal number. And how can we convert this decimal number is to binary number? That is, we can recursively divide the number by 2. Why 2? Because 2 is the base or index of binary number system, just like the decimal number is otherwise known as base 10 system. So just like that, binary number is base 2 number system because it has only two digits, that is 0 and 1. So that's why we divide the number into 2 so that we can only get the remainder as 0 and 1 form, because our binary number will only be consisting of 0 and 1s. So that's why we are going to recursively divide the decimal number by 2 and extracting the remainders. And at last, what will be our binary number? That will be the reverse of the remainders that we have got. Like in this case over here, we have got the remainder as 1001111, but the actual binary number will be the reverse of this, that is 111001. Why is that? Because when we got the remainders in every iteration, we have to multiply them with their place value. So after we multiply with their place value, we will get the result. But if you don't want to do such detailed operations like multiplying the place value, we can simply just uh, declare a string which will hold the remainder for every iteration. Then at last we can reverse the string and return it. That reversed string will be our result. So let me dry run it for you so that you can understand it a little bit better. So 57 we have at the start. So we divide by 2. We get the quotient as 28, which will serve as the number itself in the next iteration. And we got our remainder as 1. So then we again divide 28 by 2. We got remainder as 0, quotient as 14, which will serve as the number in the next iteration. Likewise, we continue this iteration until our number becomes 0. So in this order, we got our remainders. But at last, we have to return the string of remainders in reverse order, because our number or the binary equivalent of the given number will be 111001, which is reverse order of the remainder that we have got. So now let's move into the code editor and code out the problem. So let's try to understand the logic. First thing is that we have to declare a loop because we have to do the same operations again and again. So until how much iteration the loop will run, that will be decided by until when the number becomes 0. So until the number is not equal to 0, our loop will be continued. So inside the loop, we have to extract the remainder. So we extract the remainder of n by 2 because we are doing division of successive division with the number 2. Then we divide the number by 2 so that we can use it in the next iteration. We get the reduced number in the next iteration. Then we have to declare an answer string. Answer string we have to declare, in which we can append this remainders that we are getting. At last we will return the reverse string. But in Java, string is immutable. Once declared, you cannot tamper with the string value. So let me do one thing. I will use the string builder class, which is an helper class to operate with the string values. because we know string values are immutable in Java, but string builder data type or value we can manipulate with. So I have taken a string builder variable or object which is mutable. We can change it and change and shop with it according to our problem statement. So it has a method called append, which appends the required character to the answer string. So we append the extracted digit or extracted remainder with our answer, and at last we have to return it, but we have to return it in the reverse form. So it also have a method called reverse. So it has a method called reverse in the string builder object. There in the string builder class there is a method which reverses the string, and if I try to return now, it will give me an error because we are returning the string builder object, but we have to return the string object. So what's the solution? That I will write toString method, which converts the string builder object back into string. So that pretty much sums up the problem. The first thing we have to do is to extract the remainder of consecutive division by 2. Then we divide the number 2 so that we get the quotient for the next iteration. Then we append the remainder or the result of every iteration with the string builder object answer. Then we return the reversed string value. So as you can see, our sample test cases have been passed. So let me submit the solution, and it's processing. And as you can see, all the test cases have been passed and we have successfully completed our problem. So that's it for this video. If you have any doubts, you can reach me in the comments. I will be happy to answer your doubts. So till then, keep learning. Thank you.